This is part one of reviewing the exponent laws. The first rule is for products. That means when you're multiplying two terms together. So notice that both of these terms have the exact same base. When they do, I'm able to use this rule. So those two a's don't multiply to a squared. They actually stay as an a base. But when you do multiply these two terms, your exponents add together, and that's how the rule for products works. Now the rule for quotients is somewhat similar. Again, you'll have the same base for both of your terms, and those two terms, when you do a quotient, which means division, they don't divide out to become 1. They stay as a. What happens is both of the exponents end up subtracting, and that's how the rule for quotients works. So what we're going to do is we're going to apply these two rules to number 1. So it asks to simplify. Here's 4 squared, and I just expanded this to two 4's, multiplying each other. And that's going to multiply 4 to the power of 6, which is 6 4's. Altogether, you can see that you have 2 4's here and an additional 6 4's. So in total, you have 4 to the power of 8. Now that's exactly what would happen if we just had added those at the beginning. We don't necessarily have to write this step. Now we wouldn't actually go further and evaluate the 4 to the power of 8. That's going a little bit too far. You're going to get a really big number. So we can just leave the answer just like that. Okay, for the next one, w cubed, so we have 3 w's, divided by w squared, so that's 2 w's. What's going to happen is each of these w's is going to cross off, one from the numerator and one from the denominator. Those are going to leave 1's. Then we're going to do it again, and we're left with 1's again. So technically, there is one w in the numerator. So this is the same as saying w cubed minus the 2 equals w to the power of 1, and we don't actually write the 1, so it's just the w, and that represents that one lone w. These are the next two rules. A power of a power. What they mean by that is, here's a to the power of n to the power of another exponent, n. What you do in that case is you keep the same base, but then you multiply the two exponents together. Now, the 0 exponent, anything to the power of 0 equals to 1, except for 0. That's the only extra case. Okay, so really simply, number 2, x to the power of 5 to the power of 3 means x to the power of 5 times 3, which is x to the power of 15. And another way of thinking about it is, I have 3 of these brackets. So if you consider 3 of these 5's together, we just learned about when these are multiplying each other, we're going to add all the exponents together, and that makes the 15. 7 to the power of 0 is just very basically 1. Okay, so anything to the power of 0, once again, is just 1. Now lastly is the negative exponents. So when you have a negative exponent, what you do is you think about what's underneath the base. So there is an invisible 1 right there. What's going to happen is the 1 and the base are going to flip upside down, and that automatically makes that negative into a positive m. Okay, so we deal with the negative by taking the reciprocal of the base. Let's try this out. So we're going to simplify, and we're going to make sure that all the answers have positive exponents in them. So right now, 3a has a negative exponent. We don't really like that. Okay, so there's a 1 underneath the 5, and to deal with this negative, we're going to flip that 5 over 1 upside down. Then we're going to have all of that to the power of positive 2, because you've already dealt with the negative. That means you're going to have 1 squared over 5 squared, and that's just 1 over 25. Okay, now this one deals with two different rules together. R to the power of negative 5 and then to the power of 4. So let's deal with the power of a power first. That was R negative 5 times 4, which is r to the power of negative 20. Okay, so that's done. Now we have to deal with that negative exponent. So underneath that r is a 1, and what we're going to do is we're going to flip that r over 1 upside down, and all of that is going to be to the power of a positive 20. Okay, so we dealt with that negative already by flipping it. So 1 to the power of 20 is going to be 1, and r to the power of 20 is going to be r20.